Square and square roots. One, 3, 5, 7, 9, 11, 13, 15, 17, and so on. What do we call these numbers? Odd numbers. Let us learn some interesting pattern of square numbers on odd numbers. What would be the sum of 1 and 3? Sum of the first two odd natural numbers, it is 4. 4 is nothing but the square of 2. Similarly, what would be the sum of the first three odd numbers, which are 1, 3, and 5? 1 plus 3 plus 5 is equal to 9. 9 is nothing but the square of 3. And sum of the first four odd natural numbers, 1 plus 3 plus 5 plus 7 is equal to 16. 16 is the square of 4. Sum of the first five odd natural numbers, 1 plus 3 plus 5 plus 7 plus 9 is equal to 25, which is equal to 5 square. Do you observe that there is a pattern among odd numbers and square numbers? The sum of odd numbers and the squares of a number are equal, so that sum of first n odd natural numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15, and so on, n odd natural numbers is equal to n square. Now we'll learn an interesting pattern of consecutive natural numbers of square numbers. Let us see the relation between consecutive natural numbers and odd square numbers. What is the square of 3? Is it 9? How can 9 be written as the sum of two consecutive natural numbers? 4 and 5 are consecutive natural numbers, isn't it? The sum of 4 and 5 gives us 9. Similarly, what's the square of 5? 25. How can we write 25 as the sum of two consecutive natural numbers? The sum of 12 and 13 is 25. 12 and 13 are consecutive natural numbers. But the next square of odd number 7 is 49. What could be the sum? Can you guess? Isn't it tough? We have another formula of consecutive natural numbers to find this. First natural number in the sum is n square minus 1 upon 2. The second natural number is n square plus 1 upon 2. Here n is the odd number. Same thing applies in the previous sum. Let us find the two consecutive natural numbers for 49. Here take n is equal to 7. First number is 7 square minus 1 upon 2, which is equal to 48 upon 2, that is equal to 24. Second number is 7 square plus 1 upon 2, which is equal to 50 upon 2, that is equal to 25. The sum 24 plus 25 gives 49. Similarly, for all the squares of odd numbers, we can find the sum of two consecutive natural numbers by finding the first number using n square minus 1 upon 2 and the second number using n square plus 1 upon 2. Square of 1 is 1. Square of 11 is 121. Square of 111 is 12321. Square of 1111 is 1234. 321. Square of 11111 is 12345 4321. Observe the squares of 1, 11, 111, 1111, and 11111. They have a beautiful pattern. What is the pattern? By observing the pattern, we see that the patterns depend on the number of digits present in the given number. If it is a two-digit number, it starts from 1 to 2 and 2 to 1. If it's a three-digit number, it starts from 1, 2, and 3, coming back to 2 and 1. If it's a four-digit number, it starts from 1, 2, 3, and 4, and it comes back to 3, 2, 1. Here we have another interesting pattern. The square of 7 is 49. The square of 67 is 4489. The square of 667 is 444889. Square of 6667 is 4,44,889. The fun is in being able to find out why this happens. Maybe it would be interesting for you to explore and think about such questions even if the answers come years later. What is the square of 59? To find the square of 59, should we multiply 59 by 59? Isn't it tough? So we have another easy method to find the square of 59. 59 can be written as 50 plus 9. So we have to find the square of 50 plus 9 by multiplying 50 plus 9 by 50 plus 9. After simplification, we get 3,481. Find the square of 99. Similarly, square of 99 can be written as square of 100 minus 1. By simplification, we get 9,801. What patterns do you observe in the following numbers? All these numbers are ending with the digit 5. We can easily find the square of the numbers ending with 5. Let us find the square of 25. In the number 25, we have two digits. First, find the product of the first digit and the successor of the first digit. Here, 2 is the first digit and the successor of 2 is 3. So product of 2 and 3 gives 6. And the square of 5 is 25. By combining these two sets, we get 625, which is the square of 25. Let us find the square of 35. In 35, we have two digits. First, find the product of the first digit and the successor of the first digit. Here, 3 is the first digit and the successor of 3 is 4. Product of 3 and 4 gives 12. And the square of 5, which is 25. By combining these two sets, we get 1,225. This is the square of 35. You are all familiar with Pythagoras Theorem. In Pythagoras Theorem, the sum of squares of two sides is equal to the sum of hypotenuse in a right-angled triangle. The lengths of three sides are nothing but Pythagorean triplets. If the sum of the squares of the two numbers is again a square number, then the three numbers are called as Pythagorean triplet. Let us use the right-angled triangle with sides 3, 4, and 5 units. According to Pythagoras theorem, AB square plus BC square is equal to AC square. 4 square plus 3 square is equal to 5 square. 16 plus 9 is equal to 25. 25 is equal to 25. Hence 3, 4 and 5 are called as Pythagorean triplet. Similarly, 6, 8 and 10 are Pythagorean triplet. 6 square plus 8 square is equal to 10 square. 36 plus 64 is equal to 100. 100 is equal to 100. And again, 5, 12 and 13 are a Pythagorean triplet. 5 square plus 12 square is equal to 13 square. 25 plus 144 is equal to 169. 169 equal to 169. Let us summarize what we have learned. The sum of the first n odd natural numbers 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 12 plus 13 and so on. N odd natural numbers is equal to n square. The square of odd numbers n can be found by the sum of two consecutive natural numbers by finding the first number using n square minus 1 upon 2 and second number using n square plus 1 upon 2. The square of a5 is a into a plus 1, 100 plus 25. If the sum of the squares of two numbers is again a square number, then the three numbers are called as Pythagorean triplet.